Good morning or good afternoon or good evening. It's Miss Bauer here, and today we're going to talk about triangles. Now, there's all different sorts of triangles, and we can describe those triangles based on their angles or by their sides, but we'll typically use this word classify right here. Now, if you think about people, we can describe people based on their insides, like they're a kind person, they're a nice person. You can also describe people based on their outsides, like she's brunette or he has curly hair. It's the same thing with triangles. So our inside words are our angles, because angles are found on the inside. And our outside words are just the sides. And they get the name triangle because there's three. There's going to be three angles or there's going to be three sides. Now, if all three of those angles are congruent, which means exactly the same, we call that equiangular. So that's if all three angles, or all the angles, I'm going to use symbols here, are congruent. And if you remember, maybe not, that triangles add up to 180 degrees. So if I just want to find one, if they're all the same, 180 divided by 3 is 60. So each angle should equal 60 degrees if it's equiangular. Now acute, maybe you remember the word little. Acute is if all the angles are less than 90. So acute is when all three angles are less than, I'm going to be using these symbols, but you can write it out in words if you want to, all angles are less than 90 degrees. Okay, a right angle or right triangle is when one angle is 90 degrees. And if you think about it, a triangle has to add up to 180 degrees. So if we take out that right angle that's 90 degrees, we should have two acute angles left over that are complementary or that they add up to 90. You can't be acute and right. It would just be a right triangle, even though there's some acute angles in there. And our last one is obtuse, and you can only have one obtuse angle. Only one of your angles can be more than 90 degrees. You can't have two angles that are more than 90 degrees in a triangle because that would add up to something that's bigger than 180. So if it's obtuse, that means that one angle is greater than 90 degrees. Now those are our inside words. To describe the outside or classify the outside, equilateral would be if all of our sides are congruent. Maybe you've heard some of these words before. Isosceles is when at least two sides are congruent. And scalene is when none of the sides are congruent. And based on these definitions, an equilateral triangle is isosceles, but an isosceles triangle is not necessarily equilateral. So let's go back up to this picture. It says, how many triangles can you classify? Well, the first one that stands out to me is just this blue one right here. And if I outline that triangle, I could call that triangle A, E, D. The first thing that we see is these ticks all the way around. And if there's ticks all the way around, that means it's equilateral. And if I look at those angles, it's also going to be equiangular. So the first triangle that I'm going to classify is triangle AED. And I'm going to say that it's equilateral and equiangular. And this lime green one, triangle ABC, is the same. I also see this box. So that's right there on triangle ACE. And I could call that triangle ACE. I could call that triangle CAE. It doesn't matter as long as I have all three of those vertices in there. So there's my triangle. I know that it's right, but I see one tick, two ticks, no ticks, which means that all of our sides are different. So that would be an example of right in scalene. Now, there is an isosceles triangle in here. I'm going to give you a minute, see if you could find the isosceles triangle. Hopefully you got this, ACD right there. So there's our isosceles triangle. Now I'm going to ask you this question. Would it be equiangular, acute, right, or obtuse? Go ahead and look at those angles and take a second and think about it. And if you said obtuse, you're correct. So it's isosceles and obtuse. Because if that's a right angle, right angles typically make a L. It goes past it, which makes it an obtuse. Now, there's a lot more triangles that are in here, but hopefully you're starting to recognize some of these. Hopefully you've seen some of these before. One of the things I want to talk about is this equilateral and equiangular. It just kind of makes sense that if all the sides are the same, well, all the angles are the same. And we call that our equilateral biconditional. Remember that biconditional is that phrase that goes forwards and backwards. So it would go something like this. A triangle is equilateral if and only if, which remember that phrase IFF for biconditionals, it is equiangular. So a triangle is equilateral if and only if it's equiangular, and it goes the other way that it's equiangular if and only if it's equilateral. So what this means is that if I see a triangle that's equilateral, so I see ticks all the way on it, well, that means that it's also equiangular. So I can add ticks, but I can also add arcs. All those angles would be 60 degrees. It also works for the opposite. If you see a triangle that has arcs all the way around, remember those arcs mean that all of our angles are congruent? Well, then I could go ahead and add in some ticks. I know my pictures aren't drawn to scale, and that's okay. But if I know that all the angles are the same, I can go ahead and add in ticks because all the sides would be congruent as well. That's our equilateral biconditional. Just think, ticks means arcs, arcs means ticks. Now, isosceles has a similar property to that of equilateral. When all the sides are the same, all the angles are the same. But in an isosceles triangle, only two of the sides are the same, so only two of the angles are going to be the same. And we call those two congruent angles our base angles. So our two congruent sides we call our legs. The base angles are our two congruent angles. And think of that vertex angle, that's our odd angle out. That's your odd one out. And across from that vertex angle is our base, hence that base angles. Now, the way that I like to remember this is that I literally can draw a stick figure with the legs, and then the shoes would be where the base angles go. And it doesn't matter how I draw that stick figure, how I draw that triangle, I can change it up. So let's just say that our person wants to go skydiving. And I'm going to do this. I'm going to make a triangle right here. And I'm going to go ahead and call that triangle ABC. Well, if these are our legs, ask yourself in this stick figure, where would his feet go? Hopefully you said A and B. Those are our base angles. Those are our congruent base angles where the feet would go in our stick figure. And we'll do some more examples with that in just a little bit, but just remember that if the legs are the same, then your base angles are going to be the same as well. So let's take a look at these four triangles and see if you can classify these and notice some patterns. I'm going to give you a minute to look at the inside and the outside. And then go back up to your answer bank right up here. We should be picking one inside word and one outside word. Well, hopefully you were able to get that if all these angles are 60, that makes it equiangular. And if it's equiangular, it has to be equilateral. Which if you'll notice that all the angles were the same, therefore all the sides are the same, 8.6, 8.6, 8.6. Now let's take a look at this next one. I could start inside out. So how could we classify this based on the angles? Look at those three numbers. And if you said acute, you're right. Now look at that outside. Notice that they're all different. So this would be acute and scalene. And if you notice too, 44 was the smallest degree and across from it was the smallest side. That same thing comes into place in this next triangle. If you see this, automatically it's going to be a right triangle. And if we look at the outside, nothing is the same, so I'm going to say right and scalene. Now, if you remember, a hypotenuse is always the longest side in a right triangle. That's because it's across from 90, which is the biggest angle. Ask yourself, what's the smallest of these three angles? 32, what's the smallest side? 7. That's actually called hinge theorem, which we'll get into later, but just know that the smallest angle on the smallest side are opposites, which is why 90 and your hypotenuse are across from each other. It's why the hypotenuse is always the biggest side. And let's take a look at this last example. What do we notice about our angles? This one right here makes it obtuse. And look at that outside. I noticed that 2 of the sides are the same, so it's going to be isosceles. Now, I want to go back to this isosceles property we talked about a little bit ago, where if the sides are the same, which 2.5 and 2.5 are the same, they're congruent, I can add ticks. It means that the angles are the same as well. So think of this like your legs. Well, then where would the feet go? Right there at 26 degrees and 26 degrees. Also notice that our obtuse angle is our odd angle out, also known as the vertex. And what's across from it? 4.5, which is our base. So 2.5 and 2.5 are our legs, 4.5 is our base, 26 and 26 are our base angles, and 128 is our vertex angle. We can kind of see it in the picture with numbers, and we're going to do some more examples in a little bit where we find missing values. So if I take a look at this picture, the first thing that I notice is that there's ticks here and here, which would make it what type of triangle? Hopefully you said isosceles. Okay, so if there's ticks here and here, it means that these parts are congruent, and congruent means that we set it up how? Hopefully you thought part equals part, because that's what congruent means. So 3z plus 2 would equal 8z minus 33. And then I'm going to go ahead and solve for z. So in this case, I'm going to subtract 8z, because I like to put the letter on the left. 3z minus 8z would be 5z. Plus 2 equals negative 33, and then when I subtract 2, 5z would equal negative 35. Divide both sides by 5, so z would equal negative 7. Okay, now if we continue to take a look, a negative divided by a negative is a positive. My bad, that should be positive 7. Anyways, minor mistake there, caught it before I continue, which is good. Okay, so positive 7, not negative 7, my bad. Now let's talk about finding x and y. Now remember, if it's isosceles and the legs are the same, then the base angles should be the same. So if those are your legs, there's your base angles where the feet are, which means that if that's 72 degrees, x should also be 72 degrees. I don't have to add or subtract anything. I know that those are the legs. Those are legs, and the feet or the base angle should be the same. So I know that x is 72 degrees. Now, to figure out what y is, I have to remember that a triangle adds up to 180. So all that I'm going to do is add 72 and 72, which is 144, and subtract that from 180. So y should equal, go ahead and take a second to find that out. And hopefully you got 36 degrees. That's it. So let's take a look at the next one. And I do need to put this marking in here. So now that I've put that marking in there, I'm going to give you a minute to think, what does that mean about this triangle? Hopefully you said equiangular, because that's what the arcs mean, that all the angles are the same. But if it's equiangular, remember that it's also equilateral, which means I can add in these ticks here. So I'm going to go ahead and start with that outside part, and I'm going to just go from outside, work my way in. If it's equilateral, that means all the sides are congruent, which once again means part equals part. So I'm going to do 4x minus 4 equals, an outside part goes with an outside part. Don't forget that, outside with the outside. So 4x minus 4 would equal 3x plus 8. And it doesn't matter which part goes first, and when I go ahead to put the letter on the left, subtract 3x. So x minus 4 equals 8, add 4 to both sides, so x would equal 12. Okay, I found x, now all that I need to do is get y. Now remember that an inside part goes with an inside part. If it's equiangular, that means that all these angles are 60 degrees, because we know that about equiangular, equilateral triangles, all the angles are 60. So 2y should equal 60 degrees. And if 2y equals 60, divide by 2, y would equal 30. And that's how I figure out what y is. Now, most of these have two variables, and that's fine. We can go ahead and solve with two variables. We just don't want to mix and match our x and our y. So if I take a look at this next one, I see that there's ticks here, which makes it what type of triangle? Hopefully you said isosceles. And remember that if it's isosceles and that the legs are the same, that our base angles or our feet are the same. So this is like a person kind of skydiving right here. So if our base angles are the same, that means 5x could go with 75. And that's how I'm going to set this up. 5x equals 75. Because our base angles are congruent in an isosceles triangle. And when I divide both sides by 5 and I solve this out, I'm going to get that x is 15. And now I need to figure out what y is. Well, if this part's 75 and this part's 75, remember that a triangle is supposed to add up to 180. So 75 plus 75 would be 150. 180 minus 150 would be 30. So 3y should equal 30 because our vertex angle equals 30. Because if that's 75, that's 75. That has to be 30 in order for it to add up to 180. So I'm going to divide both sides by 3, which means that y would equal 10. I'm going to give you a minute to look at the symbols on this next one and then see if you can figure out what type of triangle it is. Okay, hopefully you were able to get equiangular and equilateral. So remember, if it's equilateral, all the sides are the same, so part equals part. So I'm going to do 5x minus 6 equals 3x plus 2. And then when I go to do the letter on the left, subtract 3x. So 2x minus 6 equals 2. And hopefully you're getting fast at the solving parts of these problems. Add 6, so 2x equals 8. Divide by 2, so x would equal 4. Now, if the problem actually asked for the side of the triangle, I'd have to go back here and plug it in. If it said find the side, well, 3 times 4 is 12 plus 2 is 14, which means that all the sides would be 14. But it didn't ask me to do that. It just said find x, find y. Okay, so now I need to figure out what y is. And if I look around, I don't have a number to go with it. But you have to remember that it's equiangular, which means that all these angles are the exact same. So if a triangle adds up to 180 and all of these have to be exactly the same, 180 divided by 3 would make all of these angles 60. So that's how I'm going to find out what y is. I'm going to do 5y equals 60. You could say that 15y equals 180, and you could solve that. Either way, we're going to get the same thing. We're going to get that y equals 12, regardless of how you set it up. Some people like to use this 180 rule. Some people like to remember that they all equal 60. I prefer this one because I'd rather work with smaller numbers than bigger numbers. And that's how we solve these triangles. So let's take a look at this one right here. We're going to skip this example and we're going to go straight to this word problem. Okay, it says triangle RST is an isosceles triangle. So I'm going to go ahead and draw an isosceles triangle. So I'm going to put ticks in here. But I need to keep reading to know which one is what. It says angle R is the vertex angle. So angle R. And when we label, we go around clockwise. So if this is R and I go clockwise, so R, that would make this one has to be ST. And I know that R is the vertex, is the odd angle out. It should go between the ticks, between the legs. So angle R is the vertex angle. And if I keep reading, RS is x plus 7. I'm going to put that on here. ST is x minus 1. And RT is 3x minus 5. Now, a lot of times these word problems try to trick you, but you're smarter than they are. You know how to draw an isosceles triangle. You know how to label. You know how to put this information on there. And then we can look at our picture and figure it out. There's one of these parts that we're not going to use. If I'm trying to solve for x, think about what you know about ticks. How would we set this up? Ask yourself, which part would we not use? And if you said that part, x minus 1, you're right, that's the base, because a tick should equal a tick. So there's your part equals part right there. So 3x minus 5 would equal x plus 7, and now I'm going to solve that for x. So 2x minus 5 equals 7, add the 5, so 2x would equal 12, which makes x equal 6. But I'm not done with this problem. If I continue reading, it says find x, which I've done, find RS, ST, and RT. So now I'm going to go plug it back in. If x is 6 over here, ask yourself, what's 3 times 6 minus 5? 3 times 6 is 18. 18 minus 5 would make that 13. So R to T is 13. Over here, what's 6 plus 7? Also 13. Remember, they were supposed to be the same because of the ticks. And then our last side, 6 minus 1 would make that 5. Sorry, my 5s kind of look like S's sometimes. And that's it. So from there, I figured out what x was, set it up, and matched my sides. Now look at this next one. It has the word perimeter in it. And if you don't remember what perimeter is, perimeter means the sum of all sides. And that's a good word to know. So before I read this problem out, just remember that perimeter means the sum of all sides. So an equiangular triangle has a perimeter of 54 centimeters. One side measures 5x minus 2, find x. Okay, I'm going to go back and go ahead and draw a picture. So it says equiangular. Now remember, if it's equiangular, what else do we know about it? What else could I add to my picture? I'm going to give you a minute to think. Hopefully you said ticks, because if it's equiangular, it's also equilateral. Okay, I know that it has a perimeter, so the sum of all the sides should add up to be 54. And then it says one side measures 5x minus 2. Well, if one side is 5x minus 2 and it's equilateral, then they should all be 5x minus 2. So how am I going to find the perimeter? I'm going to add up all the sides. Now I could add that all up, or if there's 3 of them, I could just do 3 times 5x minus 2, which would be 15x minus 6 if I added them all together. And that should equal our perimeter, which is 54. From there, I'm going to add 6, so 15x equals 60, which would make x, once I divide by 15, x would equal 4. And that's how we solve for x. Another way that some people like to solve this problem is they like to remember that if the perimeter is 54 and all the sides are the same, some people will do 54 divided by 3, which is 18, and then they'll set one side equal to 18. So they'll do 5x minus 2 equals 18. You'll still get the x is 4 either way that you set it up, which I know can sometimes be confusing in geometry when there's multiple ways to do this problem, but it happens that we should all come out to the same answer. Now, we're going to skip this last problem right here. Just remember that if it's equilateral, all the sides are the same and all the angles are the same. And if it's isosceles, 2 of the sides are the same, which means that 2 of our angles are the same. And once you have that, a lot of these problems just become part equals part as long as you have your matching pieces. Good luck with your practice.